Hey, it's Tony here, and today I'm going to show you a video of processing a image that was captured using N.I.N.A with the Seestar S50 and then processed in Siril and Photoshop. So with no further ado, let's get started. So to use the Seestar S50 with the N.I.N.A capture software, the first thing we have to do is to use the Seestar phone app to power on the Seestar. So we'll go ahead and do that and do the connection. And you'll see that my phone is now connecting to the Seestar. Just takes a few seconds for that to occur. And then once it's done that, we then go into stargazing and we'll skip that step there. And what we want to do is we're going to use the joystick and we're going to point the Seestar roughly pointing south and then slightly east and then about a 40 to 50 degree elevation. So I'm using the joystick to do that. And the reason we do this is this then helps, first of all, the Seestar to know where it's pointed. And then when it connects to N.I.N.A, that information is synced. So it's important, a very important step to do that. So again, power on your Seestar through your phone app, point the Seestar lens roughly facing south, slightly east, and then about a 40 to 50 degree elevation. And you will be in EQ mode as well. And then we'll go over to take a look at the N.I.N.A setup. So I've got N.I.N.A open, and if I check the camera settings here, you can see the Seestar is connected in N.I.N.A to the Alpaca driver. I can go through the various settings. Here's the light pollution filter under filter wheel, and then I can go down to the mount and the switch, turn on the dew heater. And then the next thing I can do in N.I.N.A is I can go over to framing and put in the object we want to capture, which is Messier 27, load the image, which is what you see there. And then what I can do is I can add that to a target sequence in N.I.N.A. And I just go into the sequencer and you see I've already got images being captured already. I'm making 4 out of 450 progress. Each one is 20 seconds. You notice that I've got a second segment that does the same thing. That's because mid-capture, I'm going to re-slew and recenter the target just in case the object drifts off the frame. And so that would be it for the setup for running or capturing the object in N.I.N.A. As you can see here is the progress bar at the bottom left, exposing up to 20 seconds. And then the progress again, 4 out of 450. So it's fairly straightforward to do that setup. Okay, so I've captured the image and I've done a stacking of those images in Siril. And so I've got a stacked and aligned file that I've already opened up in Siril. And you notice that I'm in linear view mode here. That's why the image is completely dark. If I go into auto stretch view, so this is just a viewing mode to be clear. I haven't changed the file in any way. But you notice that I captured, I think about 5 hours worth of frames. So about 1,000 plus frames. And as a result, you can see there's definitely some background gradients across all those frames. And you'll also see that how some of the stacking has got these edge artifacts here or edge darkness where the frames didn't quite overlap correctly. So the first thing I'm going to do in Siril is I'm going to go ahead and do a crop. So I'm going to hold down my left mouse button, drag, and let's do a crop to around about here. And then right click and crop. And the first thing I want to do is go into scripts, Python scripts, processing, and select GraXpert. And GraXpert is a tool that you can use to do a background extraction. There are other tools you can use. I'm just going to keep it fairly straightforward for the time being. So I'm going to leave everything at default in GraXpert, click on apply, and you see there that gradient has nicely been reduced. So we'll go ahead and minimize this. The next thing we want to do is go into Tools, Astrometry, and we want to do a plate solve. And so this brings up another dialog here. And I'm just going to click OK. And you see there in Siril, it's used that plate solve to understand what is the object that we're looking at, what were the capture parameters, and this comes in useful as we go through the processing. The next stage is we want to do a color calibration. So I go over to image processing, color calibration, and I'm going to select spectrophotometric color calibration. And that brings up a dialog box. And I'm just going to select here, the sensor is the Seestar S50. I did use the light pollution filter, so I select that. And I'm just going to click on OK. And you see there the colors very, very subtly changed as we did that color calibration. All right, so I'm going to use my mouse wheel in Windows, and I'm going to zoom in. And you can see I'm going to inspect the kind of the shape of the stars, and they look not too bad to me. Maybe a little bit oblong. It's kind of hard to tell. The seeing conditions during this capture was not that great, and so hence we don't get perfectly round stars. But I think I'm just going to leave them as is. If you wanted to, you could go into scripts and Python scripts processing, and there's an aberration remover here, and that will kind of round out the stars a little bit. So I won't do that in this example, but maybe you can play around with that for yourself. The next thing we want to do is we want to go into scripts and Python scripts, and we want to do a StarNet star removal. So I'm going to click on that. It's going to run the script. It's going to bring up a dialog box. And here's what I do. So basically, I select linear data because we haven't done any stretching yet of the image. Stretching meaning changing or adjusting the brightness and the contrast of the image. We haven't done that yet. So we are going to work with linear data. And then the next thing I want to do is I'm going to select what I call, or what is called here, descreen. So why am I doing that? So what descreen is, it will build out a star layer and will give me a layer that is only the stars. And it comes in handy when we do a recombine. So I'm going to run StarNet, and it will take a few seconds for this Python script to complete. And I've got a pretty fast computer, hence the time delay was not too bad. And if I go ahead and click this box here, so we've got the stars have been nicely removed. And you may say to yourself, well, that's true, but what's this weird mottling in the background? If you remember, we're still in auto stretch view mode here. And so the next stage would be to go into linear view, and we're going to go ahead and we're going to go and do some stretching of the image. So the first thing I want to do is, if I go into scripts and Python scripts, there's a couple of options here. The first one is to use Verilux hypermetric stretch. So I'm going to run that script. It brings up a dialog box. I can do a live preview of any changes, and I can zoom in using my mouse wheel and drag using my left mouse button. And you see the profile I've selected is a Seestar S50. I've got the target BG set here about 0.12. If I click on auto calc, and then it does a slight calculation or auto solving. So I'm going to zoom in here and just show you a couple of things. So you notice that it looks like the core of the object is a little bit burned out here to my eyes. And so do be careful when you use this hypermetric stretch that you don't go too crazy on this auto BG. If anything, I might back off a little bit and kind of darken that. You don't want to darken too much, because if I zoom out slightly, you don't want to lose some of this nice outer shell of the nebula that we've managed to capture as well. So I'm going to click on process, close the image, and now you can see we've got a bit more detail with outer shell showing. The next thing is if I go into image processing, stretches, and curves. Now, if I bring over that dialog here, if you wanted to, you could drag this bottom selection here over to the right very slightly. And you see what it did? It kind of darkened the background. You don't want to go too much because then you start to do what's called clipping. And I've already got a very slight % of clipping here. Ideally, this should be 0, but I'm trying to darken the background a little bit because we've got this sort of mottling effect. All right, so that's using hypermetric stretch. So there is another way you can do this, which is a bit more involved, but I'm going to show it to you. So let's close this. I'm going to undo that adjustment, and I'm going to go back in and do a stretch, but this time I'm going to go to image processing, stretches, and I'm going to go into generalized hyperbolic stretch transformations, or GHS. And this brings up a dialog box. And as I said, this is a bit more involved, but sometimes you may get slightly better results than using some of the Python scripts. So doing this, the first thing you want to do is where it says local stretch intensity, move that all the way to the right, and then move this stretch factor just a little bit. And you see that the nebula is very, very slightly starting to appear. I'm going to move this a little bit more. You see there's a bit more of the nebula. And you don't want to go too far, just so it starts to emerge. If you go too far, you start to then bring in maybe some of the noise elements in the background. So click apply, and then go over to where it says type of stretch, go down to linear stretch, click that, and I'm going to zoom in here a little bit using this plus button, and I'm going to drag the black point just to the start of the peak, not too much. Click apply, and then I'm going to iterate back to this generalized hyperbolic transformation, and now I'm going to do another stretch. So I'm going to bring this across a little bit. You see now we brought out the nebula. Maybe back off a little bit. I don't go too crazy here. So again, I'm trying not to expose noise. Click apply, and then go back to that linear stretch. And then let's move the black point a little bit to about there. If I zoom in using my mouse wheel, you can see what's taking place there. So click apply, go back to generalized hyperbolic transform. You see what I'm doing? I'm iterating. And so let's go ahead and do another stretch. Move it. And now you see I'm bringing just a little bit of the outer nebula is starting to emerge. And click apply, back to linear stretch, move that black point just to the start of the peak, apply, back to generalized, stretch again. And so now you see this slight nebula is starting to appear. I'm just going to back off just a little bit, about there. Apply, back to BP, adjust the black point, apply. And now I've done about 4 iterations. Let's go back to generalized hyperbolic transform. Now I'm going to show you another trick. So you see the kind of the outer nebula part. I'm using my left mouse button in Windows. I'm going to drag a little rectangle in that area. And then I'm going to click on this eyedropper, and it sets a symmetry point. So basically what it's doing is it allows you to stretch certain parts of the object without impacting the others. Now I'm going to move the stretch factor over. And you see what it did? It emphasized the outer shell of the nebula without stretching too much of the other areas. So I'm going to keep going, maybe to about there. I can see a bit of noise starting to appear here, so I don't go too crazy. Click on apply, go back to linear stretch, and the black point. Let's take it to about there. And I'm going to stop there. Let's close. I'm just going to click in the background. So you see what this method does is it is a bit more involved, but I would argue it might be a bit more refined than using straight Python scripts. And if I zoom in using my mouse wheel, you'll see this area here is not quite as blown out. And so I'm now going to save this, and let's just call it processed. And we click save. And we're going to save it as a 32-bit fits. And now let's take a look at the star mask. So if you remember, we did this descreen star mask, and I'm going to open that up, and you can see, well, there's one star there, but we want to stretch it just a little bit more. So I go to image processing stretches, and I look at this Asinh transformation. And what this does is it allows you to stretch the image, and it kind of retains some of the color in the stars. So if I move this over here, you can see the stars start to emerge. Now, you don't want to go too far. If you go all the way to the right here, you start to now blow out the background as well. So let's back this off. Let's just keep it to around, let's say around 200. Click apply. And then I want to go to image processing stretches, histogram transformation. It brings up a dialog, and let's move the midtones a little bit to the left. You see what that does? It kind of brings out the stars a little bit, but also I boosted the background, which you don't want. So on the very far left, we can adjust the black point a little bit. So bring that in. And you see it goes black again. Click on apply, close, and now let's just save that one as processed. Save it as a 32-bit fits. So now what we've got is we've got the nebula is processed, and then we've got the stars only is processed, and now we want to recombine them. So in Siril, you can go to image processing, star processing, star recomposition, and it brings up a dialog box. The first one is select the object that we were working on. So this is going to be, let's see here, this M27. So there's the object, there's the nebula, and then bring out the stars. So this one here. And see what we've done is we've kind of brought out some of the stars, that were removed using StarNet, and then we've also got the object. And the reason you do this is basically you want to be able to process your object without affecting the stars. So by removing the stars, you minimize the chance that those cores get blown out and become too bright. So we've got a nice image here that shows the object. It's not blown out in this area here. You can just see this little outer nebula area. We could probably process that just a little bit more if you wanted to. So click on apply, and close. Now, one thing that you may have noticed is it kind of looks like there's a green color to the image. And so in Siril, if you go to image processing, there is a setting here called remove green noise. Now, if you read the Siril documentation, it basically says, be careful how you use this. Typically use this at the end of all of your processing steps. You don't want to use it at the beginning. And so if I click on remove green noise, it brings up a dialog box. I'm just going to accept the defaults and click on apply. Look at that. So it kind of brought some of the blueness into the nebula and removed some of that green stain that we had there. So that's what the remove green noise it can do. And so now I would basically save this image as a TIFF file this time. And I'm going to save it as a 16-bit TIFF file because I'm going to use Photoshop next to process the image. So click on save as a 16-bit TIFF. Okay, so I've got my Siril processed image TIFF file opened up in Photoshop. Now, the steps that I'm showing in Photoshop, you can also do them in Affinity or GIMP, which are both no-cost options for processing your images. I just use Photoshop because I just happen to have a subscription to Adobe Creative Cloud. So the first thing we want to do in Photoshop is, if you look at the histogram up here, you can see that we've got a lighter background. Maybe you want to try and darken that just a little bit. And so I'm going to use my mouse wheel in Windows to zoom in a little bit. And I'm going to go to Image, Adjustments, Levels. This then brings up a dialog box. And I'm going to choose Channel Red. And I'm going to move this slider across just a little bit, just to the start of where that peak begins. Do the same thing for the green channel. And then the same thing for the blue channel. And you see what that does is, if you look at the color curve here, the colors kind of nicely overlap a little bit, quite well. And we've darkened the background nicely. You can still see some of the outer shell of the nebula. So if I click OK, the other thing you can do in Photoshop, if you want to, is Image, Adjustments, and then Curves. And if I hold down the Control button and then click in this outer nebula area, maybe up here, it's very, very faint, and then maybe click inside the nebula here. And if I raise this point a little bit, you can see what I've done is I'm emphasizing some of the outer nebula. You don't want to go too much here, because you notice if I go crazy, I also raise the background too much. So this is one way you can just consider, by maybe trying to emphasize that outer shell. So we'll click OK. And then that's pretty much it for processing in Photoshop. There is another couple of tricks I've done, is if I use Control J to copy the layer and then go to Filter, Other, and there's what's called a high pass filter in Photoshop. There's also a high pass filter in GIMP that I am aware of. Click on this high pass and it brings up this dialog where everything kind of goes really weird and posterized. But the main thing is, you want to select this radius just so you can start to see some of the outer elements of the object of the nebula to appear. And if you click OK, and then if you go to set the blend mode to soft light, and I'm going to zoom in using the mouse wheel, and I'm going to deselect this layer. You see what it did? Very, very subtly brought out some of the details using this high pass filter. So before, after. It's very subtle. Again, you don't want to go crazy, because we've also kind of sharpened the stars a little bit as well. So I'm going to stop there, because the thing is with Photoshop and all these, there's so many different things you can do. But hopefully this is just a beginner video that kind of gets you started and interested in processing your images. Thank you very much for your time.